welcome back to another episode of me learning C. I am going to continue from where I stopped. This is episode 5, and in case you don't know what is happening, I'm trying to learn C, so I asked ChatGPT for 50 programs to create in C, and I'm taking them one at a time. So last episode, which is episode 4, I stopped on this Fibonacci sequence. I'm going to continue with factorial of a number using recursion. So let's get into it. So we're gonna open my development folder, then open it in a Tmux window, Tmux session, and then I create a new one. This is where I run my executables. So for each project, what I do is I create a folder, and for this one I'm going to create a factorial folder, which is number factorial, then cd into that folder, to the next Tmux window, main.c, so this is the main block. So we have int, this is the function factorial, which will take in a number, and 0. So the factorial of a number, let's say 5 factorial, which is just like this. So 5 factorial would be something like 5 times 4 times 3 times 2 times 1, which is 5 factorial. And since I am using recursion, how it works is I need to first define, I need to know my base case and then how to get the other cases. So for my base case, I know that 1 factorial is equal to 1. It always has to be like that, and I know that for sure, which is the base case, which is like that is the stopping point of this. So we cannot go lower than 1, which is the base. So since I know that, so what I do with that is I come here, I go if n is equal to 1, comment, return 1, else we go, then we return. So see, you saw the function n times factorial n so let's try 2. So for 2 times 1 should be equal to 2. Just want to check if it's okay. Or let's try 3. So 3 times 2 times 1 is 6. So we should get 6 for this. Then I come here to run it. cc main.c. Okay. Let me just check this. Okay, 0 and 1. Okay. If I think part of the base case, I'm supposed to get if n is equal to 1, 0, or n is equal to 1. See. n times n minus 1. So I am supposed to get n times n minus 1. I think that was where I made mistake. Coming. Oh, so here I am just returning it. I am not doing anything with return value. So let's go print f percentage d. There we go. Factorial of 2. CC main, let's see. So I got 2. So let me take 6, which is 720. Factorial CC main, let's see. 720. Boom. This was where I made the mistake. Instead of, so it is n times then the number before it, then that times the number before it. So you go down till you reach 1. That was where I made it. I think I am done. So I go dot. Git add, I am adding it, then git commit. These are just aliases I made for git add and git commit. My bash config, git commit, factorial number, done. Then push it to GitHub. And go back to the previous. Further, okay. Done. Implement a program to find the GCD and LCM of 2 numbers. Okay, mkdir GCD dash LCM GCD LCM GCD LCM and then main.c. And we'll get GCD LCM. Alright, so I need to, what is the GCD and LCM of a number theory, and the list are 2 ways to describe the relationship between a set of numbers. Okay, so how this works is you get 2 numbers, then you find the GCD, the largest positive integer that can divide each number, okay, without a remainder. Oh, so GCD is the largest that can divide 2 numbers without a remainder, and LCM the smallest positive integer that can be divided by each number in a set. So you find the smallest number that 2 numbers can each divide. All right. Okay, let me check how to find the least common. Okay. Oh, so things that, oh, okay. Okay. Oof. So let's see, let's start. So let's go. Let me define two functions. GCD. And it's A, comma B. Into A, comma into on LCM. It's A, comma into. Okay. So I need to find. So how do I go about it? So GCD. So if I have two numbers, I need to find every number that can divide them without a remainder. Yeah. So the highest number that can divide two numbers without a remainder. So GCD. Int A, int E. So I think I'm going to pause this. I can get all the numbers that can divide A. I can also get the numbers that can divide B. So how do I compare and find the smallest? Maybe I get the numbers that can divide A and B, store them in an array, then take one array and compare it with the other and find the maybe take, oh my god, that would work, but that's usually zero. Okay, I think that's what I'm going to do. Let me check arrays and see. Array. You can initialize the array from its elements, so this can be detected automatically. So what I do is int first array I need a size. Why was there something like dynamic arrays? Because I don't know how many dynamic arrays. I need a dynamic array because I don't know how many devices each number is going to have. So this doesn't work. Let me check if there's another. Let me try and think if there's another way to achieve this. CG. Wait. What? Oh my god. I was thinking maybe or maybe or and I is equal to 0. I is less than a, and I don't know if this would work, but let me see. I want to try something. I plus plus, so I will get the and if, and let's say the number divided, if the number divided by I and the remainder is not equal to 0, let me change this to 1. If the number is not equal to 0, number so if it is not equal to 0, then we now go into the second one. That's what I'm thinking. Let's go j equal to 1, j is less than or equal to b, j plus plus and we go if, let's say, b modulo j is not equal to 0. Wait, if it is not equal to 0, that means there is a remainder. That means it is not a divisor. Wait, I'm supposed to be, if it is to write if it is equal to 0, that means there is no remainder. Then we enter this. Then for j is, if it is not equal to 0, then we continue, and then else, then if then else, then we go if, let's say, a is equal to, if, is it a, if I is equal to j, I have no idea what I'm doing. What the heck? I have no idea what I'm doing. What is this nesting though? If I is equal to j, then print. Let me go by I is the GCD, else continue. What is this, bro? But see some segmentation faults cordoned. Oh, I know call the function. Let's go GCD. So let me see if I can get an already solved example, and then we will use that. This is our same. GCD of 8 and 12 is 4. 8 and 12. So help me God. I have no idea. 1 is the GCD, 2 is the GCD, 4 is the GCD. So if A is equal to 0, that means if there's no remainder, that means it is a divisor. What if it is not a divisor? Else continue. I'm supposed to continue there. So you see 1, 2, and 4. 4. Wait, did I get it? 4 is the GCD. What? Did I get it? 4 is the... Wait, I need another. Don't tell me I got it. 54 and 24. 54. And that would be crazy. What? Yes. I had no idea what I was doing. I did not get it. 6 is the GCD. 6 is the GCD. I got it. I got it. But now the problem is... Whoa. So let me try and explain the magic. Oh my God, look at this nesting, bro. Let me try and explain the magic around, and I'll change some things. So the first thing I did, I'm going to run a for. First thing I did is I ran a for loop, and the for loop, you say if it should be less than, it should run no more than what our A is. Then here, what this modulo is doing, it is dividing and getting the remainder. So I divide A by whatever my I is. If my I is 1, and let's say A is 10, we do 10 divided by 1. If it is equal to 0, that means there's no remainder. That means 1, which is I, is a divisor of A. I is a divisor of A. Then we now enter a nested for loop. That, and this one, I am trying to run that 1 against all values of B, against the divisors of B, and checking when I and J are the same. Then if they're the same, that means that they have a common divisor. Sorry, not multiple. They have a common divisor. Then I just print it. So here, what I can do here is just int GCD. So I can just come here in GCD and I keep rewriting it. GCD is equal to I. Then here you can print F, then the percentage D. And go from the GCD. Now we go dash is the GCD. So you go cc1.c. One is the GCD. Okay, got the first one. Oh, GCD is I, not 1. 6 is the GCD. Okay, I got it. So that's it. So then to find the LCM, you can use your GCD. Please. LCM is A times B. 6 times 21. So you do A okay. So our LCM should be easier since we already have the GCD. So let's go. So results, int results. There we go. Then your result is your B times, then you go A over then GCD of A comma B. Okay, so since alright, to avoid that error, let me make this return a value. Then we go return. I am going to change the variable name. I think that's better. Results. Int F percentage D is the GCD. So we can just return results. Int is the LCM. So let me find an example. 21 and 6. 21, 6. The answer is 42. So let's see. Come on. That felt good. That felt good. Just format the code. Save. Okay, I'm done. Git add, git commit, LCD and LCM and GCD. Done. Push to GitHub. Okay. Come here. So I didn't even need arrays, dynamic arrays. How do you use dynamic arrays? Malloc function, calloc function, resizing arrays, memory allocate, then maybe counter allocate, reallocate. Oh my god, I haven't gone there yet. I think I'm going to stop here because I have to go and pray, so I will continue from here in my next episode. So see ya, bye.